Welcome back to E341. Previously, you learned about the LabVIEW, what is LabVIEW, how we can start designing programs in LabVIEW, what is the front panel, what is the block diagram, and all these basics of LabVIEW. And also, we did some simple examples in order to understand how LabVIEW works and how is the procedure of writing a program in LabVIEW. In this session, we want to go through the block diagram and the tools that block diagram gives us, and we will go through them once in order for you to see what are the tools that block diagram gives us. And then if you need some tool during the tasks that we give you during the lab sessions, then you will remember where to find them and how to use them. So as you remember, if you want to see the tools in the block diagram, we simply right click anywhere in the block diagram, and then we will see all the tools that we may need categorized in different groups. And again, I remind you, if you don't remember where to find a tool, you can simply go and click on search and then search the name of the tool that you need. So in order to start to see what are the tools that the block diagram panel gives to us, we right click here and we start from this structures palette. You see that the structure palettes consists of for loop, while loop, case structure, flat sequence, and other different tools that we may need. For loop and while loop are like the for loop and while loop that you have already seen in other programming languages, and we will see examples of them in next videos. We then go to this numeric palette. We here see the add tool, the subtract, multiply, divide, and other basic numerical tools. We also see this conversion tool, which has some very beautiful conversion tools. For example, we have this number to Boolean array. We have this Boolean array to number, which they convert numerical values to Boolean values and vice versa. You have this complex palette, which has the suitable tools to be used with complex numbers. And we have this math constants, which has some constants that are used in math scripts like pi, like the natural logarithm base, and the other ones. Even we have here Planck's constant. Then we go to this array palette. Here we see that we have different tools to be used with arrays. If we want to define arrays for you, arrays are groups of variables of the same type gathered together. So it is like vectors in, for example, MATLAB programming language, as you have previously seen. So we have a tool here which gives us the array size. We have other tools which can be used, which are very suitable to be used with arrays. We have, for example, this array to cluster and cluster to array. What is cluster and what is the difference of cluster with array, I will tell you about in next videos. Also here we have different Boolean operation tools like AND, or, XOR, NOT, and other ones that we can make use of them whenever we need them. Also we have this cluster. As I told you, I will tell you what is cluster and what's the difference of cluster and array in next videos. Here just let's see some tools of them. We have this unbundle tool and we have this bundle tool, which we may use a lot during our lab sessions, and I will show you examples of them in next videos. Another palette that is used a lot is this comparison, which consists of tools that can be used when we need to put some conditions on the way of our program design. This tool checks if the values are equal or not. This one checks is if the values are not equal or not. This one checks if the something is greater than something else, and we have other beautiful tools here. This one is also used to select between two values, and we hopefully will see examples of them during these videos, and also you will see examples of them when you are doing your lab tasks. Also, we have this timing, which we may use a lot, especially this one. This one gives us the opportunity to give some delay to some blocks of the program that we want to give delay to, and pay attention that the number that you will enter here when you are using it is in milliseconds. So if you need, for example, 3 seconds for some block to wait, you need to enter 3000 as in milliseconds. There are also other tools in this block diagram. There are other functions that can be used. This one gives us the tools needed to be used as in graphics and sound. This one gives us the tools to generate waveforms and to use waveforms. So we will use some of them during our lab tasks. And we have also this report generation, which gives us the tools to uh, give take out some result in different forms if we need them. And well, this is very rich. This functions palette is very rich in the block diagrams. But in the block diagram, basically, it gives you whatever you need to create and design a program in terms of block diagrams. So let's go. Let's start using these functions and see how they work. We start from this structures palette. You see that here we have something called the flat sequence structure. And in order to use it, let me first explain what is it. When you are writing a program in other programming languages, when you are writing it, you give the computer the information that the computer should run the program from the beginning and line by line and go further and further. Here in LabVIEW, we don't have such an option. We cannot tell the computer where to start and where to finish. What we can do is to give the LabVIEW the sequence of the wires and the blocks. So the LabVIEW starts from some block, and then the program propagates to other blocks. So when we need to do something and then do another thing after that job is done in LabVIEW, we will use this flat sequence. So don't worry if you didn't understand, we will use it through an example. So imagine that we need to click a switch and then see that one LED is on, and then waits for some seconds and see that another LED is on. So in order to do that, we use this flat sequence. So we simply drag it here, and then we just give it the size. So you see we have only one sequence here. So one task can be done inside this flat sequence. In order to add another task here, we should come here on the border of this flat sequence. We should right click and we should click on add frame after, so that the job that we need to be done after the first job will be added inside this one. So the size is small, so I make it bigger. So now we have this first sequence and we have this second sequence. So the example that I told you needed some switch and some LEDs. So we come into front panel, we right click, we go to Boolean, as you remember in previous examples. We, for example, select one switch, and in order to see the effect of the flat sequence frame, we select this round LED and we copy it 2 times to have 3 LEDs. So I put this LED inside this sequence, I put this LED inside this sequence, and I put this LED outside both of these sequences in order to see what is happening. So in order to connect this switch to the LEDs, we simply wire it to the block first, and then from the block simply continue the wiring. Also we do the same thing for the other sequence. First connect it to the frame, and then connect it to the LED. And for the last one, because we need to see if the switch is pressed or no, we put it outside the sequences. So in order to give some delay for us to see what's happening during this program when it's run, we go to timing and we put a wait here. So we need to tell this wait block to wait for how many seconds. So we right click here and we create a constant in order to specify how many milliseconds this should give us waiting. So if for example we need 2 seconds, we type here 2000 because it is in milliseconds, and we just copy this here in order to have the same wait here. Now we can go and run the program. So see all of the LEDs are off. Now we click on the switch. It takes 3 seconds for this one to start, and then 2 seconds. It takes 2 seconds for this one. You see this boolean 2 is inside this flat sequence, and we have given it 2 seconds. So it takes 2 seconds for this to be on, and then after that, after another 2 seconds, this one will be on, and which is boolean 3, and during that this boolean 4 is always on. So again, see the same thing when we are toggling the switch. So you have seen what is the application of this flat sequence frame. But sometimes our program is very big and we have so many sequences to put together, and this will take maybe so much space. So in order to avoid that, we have a good option here. We can right click on our frame and come here. You see this one, replace with a stacked sequence. What does it mean, a stacked sequence? When I click on it, you see what happens? This is the same structure, but you can see only the first sequence. You see here it is written 0. It means this is the first one. And when we click on this arrow, you see 1. This is the next sequence. So basically this is the same as the previous one. Only to avoid using so much space, we put them on top of each other in order just to show our program in a better way. That's the only reason. So we can use also that stacked sequence as an option. Okay, now that you saw the sequence structure, let's go to the next structure, which is case structure. Case structure is having the role of if in other programming languages. So if we want to do something with some conditions, we use this case structure. So if the condition is satisfied, something is true, something is going to be done, and if the condition is not satisfied or it is false, then another thing is going to be done. For those stuff, we will use the case structure. So in order to see an example of case structure, let's drag it and drop it here. So as you see, it is like the same as this stacked sequence. So true and false will be seen by clicking on these arrows. So by clicking on these arrows, we can see and what are the what is inside true and what is inside false. So in order to see the effect of this case structure, let's first delete our previous example. So let's go here and put some switches and LEDs. I put a switch and make 2 copies of it. Also I put 2 LEDs. So in order to see the difference of the true and false, I put 2 different types of LEDs. There is no reason for that. I'm just doing it in order to be able to distinguish between these two. Okay. So I put this first button as the button that controls the condition of our case structure. So we connect it to the condition, and in the true I put button number 2 and I put the round LED, and then I change this, and in the false one I put button number 3 and the rectangular LED. I will also connect the second button to this round LED, and then I'll go to the false condition and I'll connect the third button to the rectangular LED. Now everything is ready. We can run the program. So we run it continuously. You see this one, this key, this key which is named Boolean is controlling the true or false. So if I click on it, you see, if this is satisfied, if this is true, then this one can be turned on and this one cannot be turned on, you see. But if this is false, then this one works and this one cannot change this, you see. So we are seeing the effect of this case structure, which is acting as like if in other programming languages. Okay, now I stop the program. This case structure can also work with numeric controls. So in order to show you that, I delete this, and I want to tell you something here. Whenever you see that some wire is, whenever you have an extra wire and you want to delete it, or you have some extra wires and you want to delete them, you can simply do that by pressing Ctrl B. I repeat, Ctrl plus B. So you can easily get rid of those extra wires. So now I want to add a numerical control to control the condition of this case. So in order to do that, I come here, I add a numeric constant. You see, I have this numeric constant here. So now I connect it to this. So you see it automatically now changes to 1 or 0. You see, the point here is that you see 0 is written as default. What does it mean? It means that when you start running the program, the default condition of this case is 0, and what is under 0 will be run and will be done. Okay, So uh, another thing about this case structure is that sometimes we don't have only two conditions. We have maybe three conditions. Maybe we have more. So in order to add a new condition, add a new case, we can right click here and we can click on add case after. So you see this number 2 will be added and we can put what we want inside of it. So in order to put another thing here, I will copy one of these keys, and also I will go to use another LED. So I put them inside these two and I connect this button to the corresponding LED. Now it is ready to be run. So we run it. So you see that if I put it as 1, then this one is run. When I put this as 2, then this one is done. And when I put it as 0, then this one is done, which was inside this 0. So inside the 0, you see this boolean 5 was inside this 0 condition. So when I put it at 0, this one works. When I put this as 1, this one works, which is inside case number 1. You see boolean 4 is on this round LED is under case 1. And when I have it as 2, this one is run. So now I stop the program. We can do the same thing with case structures by string controls. So in order to see the effect of a string control on case structures, we first delete this numerical control and we get rid of this extra wire by pressing Ctrl B. Then we come here. One important point. You see now this arrow is broken and this run continuously button is not active. Why? Because there is some error in the program. What is the error? The error is that this case structure needs a control input and there is nothing in order to control it. So when I click on this broken arrow, I will see the error list. You see case structure unwired selector. So, and also if we click on this, we will see that the error is corresponding to this block. So this is also a useful tool in order to see what are the errors. So in order to add a string control to this case structure, we go here, we go to string palette and we go to string control, we add it here, we see that it appears here, then we connect the string to this structure. So you see it has it has 0 as default and 2 and 1 as we previously had. We can again click here and we can add case structure, or we can delete the case if we don't need it. So we run. You see now that problem is solved. So this arrow is healthy arrow, is a complete arrow, and this run continuously button is active again. So we click on it. You see we should give some input to this string. If I give 0, let's see what happens. See if I give 0, this boolean 5 rectangular LED will work because it is inside the 0, the default condition. If we give 1 to this, then this one works, and if we give 2 to it, then only this button works. So you see that You see the difference of these conditions, and that we can control the case structure through a string control. So let me stop the program. So that's it for this video. In next video, we'll continue case structures as you see here, and we will go to see some examples with for loop and also while loop.